Welcome all. In this video we are going to talk about biomolecules. Introduction to biomolecules. In this video we are going to talk about introduction to biomolecules. That too, we are going to talk about carbohydrates. We are going to talk about carbohydrates. As the name suggests, it consists of carbon and hydrogen. It consists of carbon, hydrogen, probably water. So carbon, hydrogen and oxygen, carbon and water. At the beginning they thought that carbohydrates consist of compound containing carbon and water that is present in multiples. Okay, so they are often termed as sugar. Okay, sugars, but many carbohydrates does not have sugar taste. Saccharides means sugars. So we will be talking about the saccharides or sugars as carbohydrates. But in the olden days, they were thinking that they are having sugar taste, so they are called as sugars, and they are the staff of life for most of the organisms. Because without carbohydrates, without food, we cannot live. So these are called as a staff of life for most of the organisms. So carbohydrates are compounds, as I told you earlier. It is characterized by having carbon, hydrogen, oxygen. Okay, carbon and water, you can say. So it is very important, widespread biological compound. So it's a chief source of energy. Okay, it is a chief source of energy. Probably it gives the energy. We digest the carbohydrates to get our energy for our life. Okay, so they are also the structural constituent of the protoplasm. Cellulose, one of the compound present in the plants. Okay, so what are the actual definition? They are defined as aldehydes and ketone derivatives. So aldehydes mean, you know, that RCHO. Ketones means RCOR. So they are the aldehydes and ketone derivatives of polyhydric alcohols, or in other words, the carbohydrates are polyhydroxyaldehydes or polyhydroxyketones. So basically the functional group will be OH and CHO. Okay, so carbohydrates are represented by the general formula CX H2O Y. So this X and Y is mostly different. For example, in glucose, so X and Y are same, C6H12O6. So here X is 6 and Y is also 6. And for some of the carbohydrates, probably it will be different X and Y. Okay, so next is we are going to talk about the classification of the carbohydrates. How the carbohydrates are classified. So carbohydrates, also called as saccharides or sugars. So they are first classified into monosaccharides. So in the monosaccharides itself, there are many classifications based on the functional groups. So based on the functional group, we have already seen they are aldose, that is aldehyde containing aldehydes. So they are called as glucose, and ketose, that is with keto functional group, that is ketose, fructose. Okay, and based on a number of carbon atoms, there can be an 2 or 3 monosaccharides, or basically they will be having only one sugar in it. They cannot be further hydrolyzed. So they are the basic component or the final fragment of the sugars. So based on a number of carbons, there is an triose, for example glyceraldehyde, which contains 3 carbon, tetrose, erythrose containing 4 carbon, pentose, ribose sugars, famous in RNA and DNA, and hexose, that is glucose. Okay, based on the another that is number of monosaccharides present, another one is the oligosaccharides. Okay, where oligosaccharides is classified into disaccharides. So disaccharides means 2 monosaccharides units present, example maltose, lactose and sucrose. And trisaccharides, okay, consist of 3 monosaccharides. It will be formed by 3 monosaccharides. Basically monotriose, raffinose, gelatinose. These are the names. Tetrasaccharides. Tetra means 4 monosaccharide units is present. It is cellulose and pentasaccharides. Example, verbascose. And there are so there are up to 5 we are given, up to 10 monosaccharide may be present in a oligosaccharides. Next one is the polysaccharides. In the polysaccharides there are 2 homopolysaccharides made up of one type of polymer, that is one type of monosaccharides. For example, starch, cellulose, chitin, and there is an heteropolysaccharides. Example, heparin and Agar-Agar. So these are the basic classification of the carbohydrates: monosaccharides, oligosaccharides, and the polysaccharides. Monosaccharides cannot be further hydrolyzed. Oligosaccharides can be hydrolyzed to 2 to 10, or in some books they would have given 2 to 9 monosaccharides, and the polysaccharides, when it contains more than 10 monosaccharides, then it is called as a polysaccharides. So these are the basic classification of the carbohydrates. So we are going to talk about each one of them. First one is monosaccharides. So monosaccharides, so these are the simplest carbohydrates. So these are the simplest carbohydrates having only one sugar or saccharine units. They cannot be further hydrolyzed. Okay, they will be having one functional group, aldehydes or ketones, and many hydroxy groups. So they cannot be hydrolyzed into small molecules, as we have discussed here. Earlier, they cannot be hydrolyzed by small molecules. So it is classified into 2 headings. Basically, we have already seen, depending on the functional groups and depending on the number of carbon atoms. So based on the functional group, it is aldose and exose. Okay, so they are divided into 2 groups, that is aldose and exose. Aldose are monosaccharides which contains one aldehyde group. Okay, aldehyde group basically CHO. So example is glucose. So example of this compound is glucose. This is one of an example of the monosaccharides, where this is the aldehyde groups as given in the video. It is the aldehyde group CHO, and there is 1, 2, 3, 4, 5 OH group. So pentahydroxy aldehyde. So this is an example of a monosaccharides, and which is having an aldehyde, and there is a next one is ketose. So ketose is having one keto group. For example, they will be having one CO molecule per one CO group per molecules. Example, fructose. For example, here it is the keto group. Okay, C double bond O, bottom C, and in the top also C. It's called as a keto group. For an aldehyde, there will be one H attached in this carbon, but here you will be having a 2 C attached to this CO. That is a keto group. Okay, so based on a number of carbon present, for example, there can be 3 carbon, 4 carbon, 5 carbon, up to 6 carbon. So they are called as triose, tetrose, pentose, and hexose. So triose, tetrose, pentose, and hexose. So triose, carbohydrates with only 3 carbon atom. For example, 1, 2, 3. So there are 3, 1. So here we have 1, 2, and 3. Example, glyceraldehyde. Example is glyceraldehyde. Next one is tetrose. So which contains 4 carbon atoms. So formula is C4H8O4, that is C4H2O 4 times. Example, erythrose. So I got 1, 2, 3, 4. So 4 carbon. So it's a tetrose. And pentose means it contains 5 carbon atoms. So it contains 5 carbon atoms, C5H10O5. Example, ribose, which is present in the RNA, very important compound which is present in the RNA. So I got an aldehyde, 1, 2, 3, 4, 5. So it's an aldopentose. So I got an aldehyde as a functional group. So hexose, famous example, glucose with 6 carbon atom. So 1, 2, 3, 4, 5, 6. So 6 carbon atom, which is called as an hexose. Okay, so oligosaccharides. Next one is oligosaccharides. So oligosaccharides, as I told earlier, it consists of 2 to 10 monosaccharides. So it contains 2 to 10 monosaccharides in their molecules. In an oligosaccharide, the monomers are linked by a glycosidic linkage. A glycosidic linkage is basically an ether linkage which is formed by the removal of water from the 2-hydroxy group of the two monosaccharides. Two monosaccharides. For example, a glycosidic linkage is a type of a chemical covalent bond that joins a carbohydrate molecule to another group, which may or may not be another carbohydrate. So it may not be a carbohydrate, but basically it is a ether linkage between the, here we have shown ether linkage between the two monosaccharides. Basically it is formed by the ether, that is glycosidic linkage is nothing but a ether linkage which forms the basic of the carbohydrates. Okay. So disaccharides mean two monosaccharides. Okay, two monosaccharides when they combine and remove a molecule of water, they form a disaccharides. So they are the most abundantly naturally occurring oligosaccharides. So mostly they are water soluble. Mostly, for example, sucrose, maltose, they are water soluble, and they are formed by the union of two molecules of monosaccharides. Okay, as I told you, one molecule of water is removed while they are combining. Okay, to form a glycosidic linkage. So maltose is an example. It's also called as a malt sugar. So actually maltose does not occur in free in nature. Okay, so how it is formed? It is formed by the condensation of two molecules of glycopyranose in the alpha position. So what is an alpha position and what is an beta position? We will be talking about in the structure of glucose. Okay, the structure of glucose. In the later videos we will be talking about the alpha linkage and the beta linkage. Okay, so maltose is a product of hydrolysis of starch and glycogen by amylase and phthalate enzymes. Okay, these are the enzymes which can hydrolyze starch and glycogen. So enzymes, you know, they are biocatalysts which have variety of application in the human body, which when combines to when they react with a starch and glucose in presence of water, they will give maltose. Okay, maltose contains two glucose units, so they will be hydrolyzed to form two glucose molecule under the influence of the maltase enzyme. So maltase enzyme hydrolyzes maltose. It is not as sweet as sucrose. So sucrose, we know it's a common sugar which we use, but it has got free functional group. Sucrose does not have a free functional group, which we will be seeing in the later videos. Okay, the maltose, sucrose is formed from the two functional groups of the glucose and fructose, whereas maltose will be having one of the glucose functional group free. So it reduces copper solutions and forms ozone. That's a characteristic reactions of aldehydes. Okay, which you might have studied in your 12th. So maltose in presence of yeast ferments readily. So it actually ferments readily. So this is the structure of the maltose. Okay, this is the glycosidic linkage, and this is the two glucose units which we have discussed. So next disaccharide is lactose, which is present primarily in the milk. So it is formed by the condensation of glucose and galactose. So glucose and galactose, so which when hydrolyzed by an enzyme lactase, probably in our milk, when the milk is hydrolyzed, you will get one molecule of glucose and one molecule of galactose. Okay, so lactose forms white gritty crystals on concentration of milkway. So it is not so sweet as others, like sucrose is not that much sweet. So it is not found in plants. Of course, it is found in the milk, so it is not found in the plant. So, but it consists of a free functional group like maltose. So it can reduce the copper solutions and forms ozones, which indicates the presence of a free aldehyde group in the molecule. So this is the structure of the lactose. Okay, two units of 1 unit of glucose and 1 unit of galactose. So next one is sucrose, the common sugar which we will be using in our household. So it is present in sugarcane, beets, carrots, sweet fruits. So it's very sweet, crystalline and freely soluble in water, that we know, but it does not have an aldehyde or keto groups. So aldehydes and keto groups are condensed in this sucrose. So it does not reduce the copper sulfate, so it does not form osazone also, unlike lactose and maltose. So, okay. So it is formed by the condensation of the fructofurans. It's monomers of fructofurans and the glycopyranose. So it's very important sugar and the main carbohydrates for the plant. So here you have got a glucose unit and the fructose unit formed by the glycosidic linkage. This is the glycosidic linkage. So these are the two units. This is the 6-membered pyranose. This is the 5-membered fructanose. So of the fructose. So next one is trisaccharides. Contains 3 monomers in their molecules. Monotriose is an example of a trisaccharides. So it is it is made up of 2 molecules of galactose and 1 molecules of glucose. So 2 molecules of galactose and 1 molecule of glucose makes the monotriose. So this is the molecule. So this is the structure of the molecules. So next one is raffinose. Raffinose contains 1 molecule of glucose and a molecule of a galactose and a molecule of a fructose. So this is the structure. So this is the glucose unit. This is the fructose unit. So this is the structure of a raffinose. And gentianose. It is formed from 2 fructose. 1 fructose and 2 glucose unit. So it is obtained from gentine root. So it is called as a gentianose. So structure is something like this. So you have got an fructose unit there, 2 units of glucose. Okay. So the next is the tetrasaccharides, which contains 4 molecules of monosaccharides. So one is the stachose. It is composed of D-glucose, fructose, and 2 molecules of lactose. Where it is found? It is found in the haricot beans, and the structure is something like this. Okay, it's some complicated structure. So for the reference, the structure is given. Next one is polysaccharides, which contains more than 10 monosaccharides. So more than 10 or 10 to many thousands of monosaccharides. Probably in the starch there will be like 10,000 glucose unit present. So unlike monosaccharides and disaccharides, they are often insoluble. Probably starch is not soluble in water. So they do not have a reducing power and never have a sweet taste. Okay, that's one of the important characteristics of the polysaccharides. So these are hydrolysis produces molecules of monosaccharides. Okay, that we have already seen. So for example, they can produce 200 or even more. What do you call as the monosaccharides. Okay. So there are 2 types, as we have seen, homopolysaccharides. So it contains same type of monomers in its molecules, and hydrolysis gives only a single monosaccharide constituent. Okay, for example, starch. Okay, it contains only glucose. So they will be having only 1 type of monomer. Okay, starch. That's the starch. It contains of 2 units actually, amylase and amylopectins. Amylase is water soluble, amylopectin is water soluble. Amylase is less branched, whereas amylopectin is more branched. Okay, it is found in abundance in plants, seeds, and fruits and tubers. This is a characteristic test for an starch. With iodine starch forms an adsorption compound, which is blue iodide of starch, which normally we use it as an indicator in our lab. Okay, so this is the basic units of the starch. It consists of 300 to 600 units of glucose. Okay, so next one is cellulose. Okay, cellulose. It is found in the cell walls of the plants. It contains many beta glycosides. Okay, many glycosides. So beta bonding we will be studying in the later videos. Okay, it contains thousands of monomers of monosaccharides. So the long chain of cellulose are further strengthened by hydrogen bonding from one chain to another. So that's a character which gives the characteristic strength of the cell walls of the plants. So cellulose are present at cell walls. It is absolutely insoluble in water and resistant to action of dilute acids and alkalis. Strong acids hydrolyze it to one glucose. So this is the basic unit of a cellulose. So beta this is made up of glucose, beta glucose. Next one is chitin. It's a structural chemical forming the cuticle of the insects. Okay, it also forms the cell walls of the fungi. So it's very tough and durable. So this is the what you call as an structure of the chitin and monomers of the chitin. Okay, then heteropolysates, they contains different kinds of monosaccharides, probably, and also sulfur and other sulfuric and other acid molecules, which will be part of the polymer. For example, heparin. Heparin, also known as an unfractionated heparin (UFH), which is used as an anticoagulant, as blood thinner. Okay, it is used to treat and prevent deep vein thrombosis, pulmonary embolisms, and arterial thromboembolisms. Okay, it is used in the treatment of heart attacks, unstable angina, also in injection into the veins. It is given by injection into the veins or under the skin. These are the some of the usefulness of the carbohydrates. Actually, without carbohydrates may be used only for energy. It is also used in the medical also. So these are the some of the units. You see here the sulfate group present in this group, and also an amino sulfate groups present in this. This is the structure of the heparin. Okay, and this Agar-Agar, which is a jelly-like substances obtained from the red algae. Okay, basically Agar-Agar, if a biotechnology student, they will be knowing the Agar-Agar, which is used as an substrate in the studies. Actually, it's a mixture of two components, linear polysaccharide agarose, and the heterogeneous mixture of the small molecules called as an agropectin. Okay, it forms the supporting structure in the cell walls of certain species of algae and is released on boiling these algae. And this is the basic structure of the Agar-Agar. So with that, we come to the end of this video. We will meet in the next video with probably structure of the glucose. Thank you.